Is that possible that somebody could manufacture this granite vase right here?
Sure, anything's possible. I don't think we've seen it done yet.
You don't think?
I haven't seen any spherical objects manufactured to this level of precision. Complex spherical geometry. We have seen it in cylinders and other objects. Flat planes, yes, can exceed that dramatically, actually. And circularity, for instance, like an artillery barrel of like a military cannon.
Yeah.
I think that first reached, like we're talking about radial deviation, basically, first reached about 1,000th of an inch in the late 1800s. So this has been possible for a while, but as applied to even metal and other complex objects, it's been 80, 90 years that we've been able to do that level of work in metal. But we haven't seen it applied to a hard igneous rock like this.
What rock specifically is this?
That's red Aswanian granite.
Okay. I can feel with my thumb, it's a little bit, you can feel like the imperfections on the edge.
Oh, and there are. And you can see tool markings. You can see what looks like the evidence of hand tools that may have been applied lastly to smooth out some edges and fix a few imperfections. They're not 100% perfect, and there's evidence of somebody's hand guiding some sort of a tool on a lot of these. So I wouldn't speculate and say they were made on an assembly line without human intervention at all.
So there's no evidence that you've seen of anybody recreating something like this in modern times.
He reached out.
Talk about that one. Yeah.
He reached out actually to granite manufacturing company or some company in China who is making vases, like multi-generational company, and they were not able to hollow out the interior. So basically they drilled a straight hole in it. And if you're talking about the external median circularity is like 110 microns. It's like 4,000.
They were using computer-controlled
inch.
CNC machines.
This is a CNC machine.
Yeah, on a lathe. So the thing was spinning, and then the CNC head was going around it.
And that's the video of it on the right.
There is another object they are working on.
That's obviously not granite.
Yeah,
it's marble, I think.
And they were hand polishing it. So the tolerances are like not even close to this one.
Do you have a photo of the inside of that vase? Or just the diagram?
I have just this diagram.
Okay. Wow, man.
The interior is more perfect. Let's say it's 3,000 and the exterior is 4,000 of an inch.
Because cylinders are easier to work than complex spherical geometry.
And when I put the order for these to print, I wanted to order a stainless steel CNC version of this one because we have the STL files, we have the scans, so they could reproduce it. And a few days after I submitted the order, they reached out to me via email that, sorry, we cannot make it. We don't have, not out of granite, out of stainless steel.
Who
it was a manufacturing company in China who printed these. They had another service to CNC, to create CNC machine parts. And they said it's too complex for them. They don't have the proper machinery to do it.
And what about these little ones? Are these 3D print recreations of existing vases?
Yeah,
like they make them this tiny.
They are from the Petrie Museum, and actually
prints are here.
This was the most perfect. This had the median circularity of 70 microns.
That's how big it was?
Yeah, and
this was
the opening just
super
broke.
symmetrical.
It's like a shot glass.
2,000ths of an inch median.
It's hard to say, but there was some sort of a lip.
2,000ths.
And it's diorite, not granite. Diorite.
Dude, that is mind-bending. And this is the actual size of it.
Yes, that's the actual size.
Have you shown this to any sort of granite workers? Like shown them this thing, how tiny it is and how perfect it is, and like ask them like, give me your first reaction to it.
Not me.
Whenever that
this is for people that can't see this,
yeah.
that people that are just listening. This thing is like, I don't know, a third the size of a shot glass.
It's like an inch and a half tall.
Yeah. Sorry, what were you saying?
Granite carvers don't usually attempt to make things like these objects. They're complex, is I think the word. You have like parabolic shapes in the exterior, dimensionality. You have very small radiuses applied to all surfaces, like the bull nose of the interior mouth you were looking at earlier. So it's not something that's normally attempted. And so if somebody is going to speculate, you will hear a lot of people say it's not possible. We can't do it today, even with modern tech. People have said that, and I don't think it's true. I think the better question is, how would we do it? Right? What would make sense? What would be efficient? Or how did or why exactly? Why did someone make this in the past, and how? Because it's looking more and more like it wasn't that difficult for whoever did it. Given the sheer number of them, given sometimes they're haphazardly finished by hand in certain cases.
And I also think it's interesting that, correct me if I'm wrong, but there aren't any two that are identical. Is that true? Which would, I mean, some people would hypothesize that maybe they had molds for these things and they were melting this granite down into liquid and then putting it in these molds and like forming them like concrete.
No two pieces of stone are identical, right? Whereas concrete could be more homogeneous, but we have seen some forms repeated over and over again, and even the nominal measurements, like the dimensionality, the same height could be applied. So here's an example of 4 of them side by side. One of them's right in front of you.
But it's not exactly the same.
They're close. They're very close. And so, these are, funny enough, I think these are all attributed to very different epochs. The one on the far left is 27 or 2800 BC, and the other ones range all the way down to the Middle Kingdom, which is like 1500 years later.
Wow.
And we have, I think, granite, obsidian, either limestone or, what does that look like to you?
The black one is what?
Not obsidian, basalt. I'm sorry.
Basalt, yeah.
Do you think that's is that limestone on the right?
They're all the same general shape.
Okay.
They're all the same general idea, but you can see how like they're very, very different. Like this, it's like you gave somebody like the general like layout of what you wanted them to build and they went for it. But it's clearly that these weren't all like from a mold.
And
because they're although they are super similar.
Check out the interior, the shoulder.
Wow, dude, how in the hell? So the fat part is completely, if you stick your finger down there, it opens up on the inside too.
Yeah.
And there's like a perfect, right where this is, there's a perfect ledge on the inside. And this is what again? What is this made of?
That's a type. I think that's a type of granite.
Okay. So.
Is that a real one?
Yep.
Yeah.
This is an original.
Yeah.
I'm glad it's hard to distinguish. It means the prints are good.
Yeah.
Yeah. It looks like, I don't know what the hell. I mean, it feels kind of like concrete, but it's definitely not concrete. You can see all the like the pattern in it.
We scanned a few alabaster and also pottery vessels just to compare if they did pottery, what's the circularity of those objects. And I always wonder if they can do pottery. Why would they go for the hassle and make this one
right
and make it so round? Why? What's the purpose of that? If they can do it out of pottery, which is less round, it's much easier. Was it some kind of a religious function, or they made it because it was holding a sacred
like
liquid,
clay, like clay pots or something like this?
Yeah. I can show
the sacred juice of life.
So basically there was a Nagada vase, this pottery vase, which we have scanned, and it's 2/100ths of an inch median circularity. I had to remove it has 4 handles actually, as you can see here.
2/100ths. So it's still very symmetrical.
Yes, but not even close to these granite vases.
Which are what is it again? Not 200.
2,000ths.
2,000ths.
Yeah, and less.
And
so it's 10 times more. 10 times more perfect.
Yeah. We have scanned also an alabaster from the 18th dynasty. So
that thing looks super oblong.
Yeah.
Well, the bottom is wacky, but if you set it straight, it's much better. The bottom will be not that straight, but
okay.
the rest is good.
I see.
Maybe I can zoom in a little bit. So it was 500 microns, which is also roughly 2/1000 of an inch.
Wow.
Sorry, 200s.
200.
So it's similar. It's in the same range like the pottery.
Okay.
But we have seen actually very nice alabaster vases, like tall ones in the MFA Boston, and it was around 100 microns, so 5 times more accurate than this alabaster. So there are a few alabaster which are in the same category like these granite vases.
How hard is alabaster?
It's much softer. I don't know
soft.
the Mohs scale, but
About
it's
a 3. It's you can cut that without an abrasive, with like a bronze tool and no abrasive.
so it's much softer.
Yeah.
But yeah,
So you think this was just super easy for them to do?
I don't know if I'd say super easy. It could have been challenging, but they did it, and they did it at scale.
Do you think it's possible that this stuff wasn't even from what we think it was from? Do you think it's possible it was like much older than this? Like maybe even like older than 12,000 years old?
It's hard to know. You know, there's a break in the archaeological record between around 5,000 BC and 10,000 BC where we don't really see these. And so if it was from a culture right before where these are normally attributed to, we think we would see that. If it was from a period of time much earlier, then maybe what you're saying is right. I don't know, but I don't. I tend to think.
How do they do that? How do you determine that there was a gap from when we see them? Like how do you date these?
They're found in burials. So the dynastic Egyptians would bury their loved ones with these, right? And sometimes kings and pharaohs would find these in.
All of them are found in burials.
Yes, but the funny thing is some of them were buried themselves. So there was a pharaoh named Djoser in Imhotep. They put at least 40,000 of these down below the step pyramid. I actually think it was much more, like more like 100 or more, by themselves. So not with bodies. They were packaged up in thousands of containers to protect them.
So with nothing to carbon date.
No, but some of the names sketched into them were from kings even earlier, hundreds of years before.
Sketched
these
into the
guys.
vases themselves.
Etched in or scratched in, if you will.
Wow. Okay, so that would be good evidence. That would be a good way of dating it.
Well, yeah, you have a minimum. You have a minimum age. You know it's someone before you, but that was Menes or Narmer, who allegedly was the first person that united Egypt. And so if his name is in a lot of these, maybe he was collecting them too. And it turns out a pre-dynastic culture called Naqada was found with these.
Well, just because you find them buried with pharaohs or have pharaohs' names etched in them doesn't mean they made them. They could have just found them.
yeah, exactly. If you go to the Cairo Museum, the new museum, and I think it's also in other museums as well, but if you look at those vases, sometimes they have the museum label, the serial number of those. And specifically in the New Egyptian Museum, I've seen one big vase with 3 different labels. The first one, one was from the current museum and another one from the previous one. And what if they did the same? Like they found these, they labeled them, and then you see multiple inscriptions on these vessels and containers. And it's not the real owner or manufacturer of the vases, not the original guy who made it.
Right. Yeah, I don't understand the controversy here, because it's an insult to anyone's intelligence to show them these scans that you guys did and say that they were done with pounding stones and copper tools. Like it's just not logical in any sense of the word.
We were talking to Miano recently, and he acknowledged that potentially they did have a lathe or revolving equipment. But right now, that's not what's attributed to any of these cultures. They didn't have the wheel. The wheel came from Mesopotamia after Naqada.
Yeah. So, what year did they come? Did they have? Do you know what year that they actually got the lathe? Like when was the lathe first introduced?
It was around 3000 BC, roughly speaking. We don't know exactly, but it was found in Mesopotamia first, and then apparently shared with Egypt. But these were turned. You can see evidence of turning marks on them. These would predate the wheel being in this region by several thousand years. And if these were made on something rotating, which it seems like they certainly were in a lot of cases, it was part of the process, something revolving, either a wheel or a lathe or something like that. But that's interesting because that culture that allegedly made these Naqada, they didn't apply that that process to anything else. Their pottery was not made on a wheel; it was made by hand. They would pinch it and draw it in coil, and so that seems very odd that they would have this tech that's only used for stone, that's so wonderfully efficient, and they would never use it for anything else. These people also didn't put stone in their homes. They didn't make headstones. They didn't have monuments, statues. They didn't have toilets, sinks, basins. And if you could cut and carve stone this easily,
Right.
or this proficiently, you would apply it to your primary residence and other
Yes.
churches, whatever, important buildings.
Yeah, no, that makes sense. And one of the arguments I think Flint Dibble made to me, not about the vases, but about the pyramids, was that like certain things need this, they would be incentivized to make certain things better and more precise if they're monumental. And he used the analogy of like Washington, D.C. He's like, you see the Washington Monument? Now, are all the houses in the neighborhoods around that monument, are they as precise as the Washington Monument, or as enormous and like well crafted as that? No, because they weren't. That was like a monumental ceremonial thing, right? And you don't need the houses; they could be mud huts, living around there. And I don't know.
Sure.
I don't know if that argument applies to the vases, though.
Well, the Hoover Dam's one of the biggest things in America. It's one of the biggest, constructions that men have ever made. But we use the same technology in other things. We know how to use cement and other things. Why? How come this technology was never applied to anything else ever? And you easily could. You could say, "Oh, look how they're spinning that stone around. I should do that with my clay." Right. And so that's it leads me to think these are inherited even to this culture. They were heirlooms. That this is not a very rudimentary culture. I would say that they're impressive. It was a society. They traded. They were all over the world.
Which culture are you talking about?
Nakata. So they traded with the Levant, with that area all the way up into Syria, southern Africa. They did have copper. They were using it to hunt. They made beer. They had breweries. But they lived in mud huts. They had very limited uses of wood, and they weren't known for applying anything like this to any other facet of their life. So these were found in Nakata burials. That's the earliest record of these being found.
Possibly. Sometimes they don't even, or they cannot even date it. Because if you look at the museum provenance, sometimes it says that possibly Nagada, or it was found in this grave and that grave, which is dated to Nagada. But sometimes they are not sure. They just write early dynastic or Nagada or pre-dynastic. So it's not straightforward when were they made.
Right.
The thing I had on previously, that was the small one.
Yeah, I just can't get over how insane this is, man. It really is crazy.
This is how it looks like.
So that's the real one.
Yeah.
And this is in the Petrie Museum?
Yes. Yeah. And so it's like possibly
and how
Nagada.
thin? I mean, it's pretty thin, the walls of this thing. Like
The interior is reconstructed because the laser scanner cannot capture the inside of this.
Right. So how thin was the real one?
We couldn't measure it because we had a precision caliper calibrated to a few microns, but it wouldn't fit. The opening is so tiny.
When Matt was here, he had some of his vases, and we turned all the lights off, and we shined a flashlight in there, and you could see the whole thing lit up because it was paper thin. Like the edge, the sides of this granite vase were literally paper thin. It was completely insane, and like
this one was very thin.
Yeah,
you can feel the thickness of this. This is a very weird shoulder
very thin.
jar. This is from the 6th dynasty, sorry. So this is not pre-dynastic on paper. But the interesting thing about this piece is the actual measurements. So if I open it up, the exterior is basically 140 microns, which is 5,000 or 6,000 of an inch.
Okay.
That's the exterior, and the interior is 1,000. Wow! So the interior is more precise than the exterior.
Like the Serapion boxes, it's the same thing, right? The interior is super precise, but the exterior is like really rough and rugged.
Yeah.
Have you been trying to come up with any sort of theories on how they could have done it?
Yeah, like he mentioned Chris King. We speak to machinists and stone carvers, and so we welcome their ideas, and maybe that helps formulate what we think might have happened, and then hopefully we can rule some things out over time. But when you're talking about today, when we're making a baseball bat and we're spinning something around at a high RPM on a lathe using a fixed cutting piece, that doesn't seem to be a good explanation, because it would strike these hard crystals in the ground mass, like the quartz and the feldspar. It would get sucked into the body. And so you're really, I think, talking about something that's removing material in a very unbiased way, like evenly. And that's grinding. And we have grinding techniques that can achieve this level of accuracy that don't need to be computer controlled or anything like that. However, this is complex spherical geometry, so we're not going to be able to explain all these little thin radii everywhere and the contouring with that explanation alone, or the interior.
Chris King thinks that basically if you have a very sophisticated lathe made out of primitive materials like dark African, I think, blackwood, and very hard materials, you can make something round to like 100 microns, 2000 or something like that. He thinks it's possible. The problem that we haven't seen those sophisticated tools from this culture. They haven't found. And if we go down to the level of this one, I think that's a different level.
What does he say as far as like what type of tools they would need to be?
You could do this work with wood and stone. You wouldn't necessarily need metal. But it has to be calibrated and fixed in a very rigid spindle. Your axis of rotation has to be extremely rigid and fixed. That's how you impart roundness and transfer roundness from something that is round or moving in a round fashion to something that you want it to be. And so I think it's possible that you could build a machine out of wood and stone. But you have to know what you're doing. And that would be, that's never been described or documented by any of these cultures, the Egyptians or the Akkadic cultures. But the Egyptians documented everything, right, in their lives. I think that's well known. Right. And they documented extensively processes for making pottery, making furniture, and things like that. So they never mentioned these at all. They never really mentioned any of the megalithic projects that we see out there. And if they had the capability of doing them, especially something that appears to be mundane, yet they never mention it at all, we don't see other records of revolving or rotating tools. We just don't.
So if it was used with stone, would they also have been able to use stone to grind down the boxes and make the boxes so perfect? Or even use stone to make the cuts in those big rocks that you see like around the pyramid that Ben talks about that look like big circular blades, cut them?
Possible. I don't think that explains everything, no. They certainly could have had metal, but if you're asking where the tools were, they used copper for thousands of years, and we found 10, maybe 20 copper saws total, ever. So if millions of people were using something for thousands of years and we found 10 or 20, that could give you an example of how tools might not survive.
But what if they had iron tools? That's a very nice idea. I think that would elevate or put this entire question or race topic on a different level. And recently I have interviewed a German gentleman on my show, and he was the guy who sampled the Khufu graffiti in the Great Pyramid.
Who did what?
He sampled the Khufu graffiti.
Oh, okay.
And there was a huge Interpol case. Zahia was trying to put them in jail, etc.
Whoa.
Yeah, it was very big. And
why did they try to put them in jail?
Because they had permissions to sample, special permissions to take samples from the King's Chamber ceiling, because they found interesting black tongues, like some kind of tool marks, like some residue on the ceiling blocks. And they sampled that. They had some time left, and they went up to these relieving chambers, and they also sampled the Khufu graffiti. That's the main inscription in the Great Pyramid, which is
they were naughty.
Attaching,
they did a little extra.
Which is attaching the pyramid to Khufu. And they had permissions for this from the guards who were with them. But after they tried to release the results, they tried to announce something about it. There was a huge case of that. But they found magnetite in the king's chamber.
What's that?
It's like a residue when you have a very rudimental iron smelting process. They found this iron residue with some magnetite in the king's chamber on the ceiling blocks, and they made an experiment. They created 16 tons of concrete block, and they have made some kind of U-shaped holder, put it underneath this block, and there was a space where you can put some metal wedges inside, or basically underneath this block, and they hammered in these wedges, and they could elevate this 16-ton block in like 1 hour, 10 centimeters with 2 people. And their idea is that that's how they elevated and moved these huge and massive granite blocks. And
with iron.
And they also found some iron tools in the Great Pyramid. There was also iron found, I think, in pre-dynastic era. So probably they could have iron before. I think iron tools were first mentioned, like iron smelting is beginning with the Hittites, if I'm not mistaken.
Well, there's a guy on YouTube who does this stuff, who moves these big blocks using just like gravity and pulleys and stuff like this. You've seen this guy?
He built a Stonehenge in his garden by himself.
Well, there was 2 guys. There's one who does like YouTube videos. There's another guy who had this place Coral Castle, which is in South Florida, who elevated these.
Lead scaling.
Yeah. And he did that not that long ago, and I forget the guy's name who does the stuff, but he basically takes these giant blocks and he like uses big wood levers to like rotate them and like to move them into place, and it's wild to see. So like if they were able to understand physics well enough, it seems reasonable that they could have moved some of these blocks into place and like stacked them in a certain way, but still like. It doesn't explain the cutting though. It doesn't explain the cutting and like the perfection of the edges of the Great Pyramid, which are like, if you measure the outside of the Great Pyramid, it's like 10 times more square than any of the skyscrapers in Manhattan. Like when you have to build a skyscraper, they have to be, according to code, within a certain deviation of like perfection before you can start building it. And the pyramid is like 10 times more perfect than even like the biggest skyscrapers that we have. So like it doesn't really explain that.
And that gets into the time it would take, right? There's no way you're going to fit that degree of work into a 20 or 25 year timeline.
Yeah, and the conventional explanation is that how long did it take to build the Great Pyramid?
Well, they think it's still supposedly 20, 25 years, something like that. Funny enough, though, in South America, they don't think that. You can ask someone about Teotihuacan, and they may say, yeah, it probably took 100 years or more.
Oh, really?
How could you have done it in any other timeline? That would be a minimum. So it depends who you ask.
Yeah.
So my point was that I think if they would have iron tools, it would be a completely different conversation. And my problem with Flindible's explanation, if you have a compass, you can make a round feature. Yeah, you can do that.
If you have what?
If you have a compass, which
a compass. Yeah.
But you still have to hold on to the piece.
Right.
Which, have you seen these large vases in the British Museum in London? It's huge. What kind of tool would you put it in? Like it's like a big boulder.
Mm-hmm. Really? You have a picture of it?
Maybe Steve, if you, I'm not sure.
I'm sure you can find it.
I don't have it here.
Right. So it's so big that they wouldn't be able to use like a lathe.
Oh, I have it here.
The piece has to be affixed somewhere, right? So if you only have one point, you generally would want 2 for stability, but whatever's carving out the interior, assume it's like an L-shaped in order to get it in there to hollow that out.
Yeah.
The longer you are away, the further you are away.
Look at the people and look at the sizes of these 2 on the right. Just a minute, a second. These ones.
Oh wow!
So
holy cow!
And this is the end product. If you look at the raw material, it's much larger.
Right.
And this is the explanation.
Oh my God.
Like this.
So that's what we were talking about earlier from Tombs of the Nobles and
This is works.
the other
So the same
explanations.
people who carved this depiction are supposedly the same people who made the pottery.
Yeah, but this
Well,
works
funny
for
enough,
alabaster.
no. This was made almost 2,000 years later than the traditional dating.
Oh, really?
Yeah.
Interesting.
Yeah, and some of these were actually painted on like stucco walls.
Yeah, it's 6th dynasty. If I zoom in, I cannot. Yeah, the painting itself is 6th dynasty, and usually these big vases are much older. But this painting or this depiction works for the alabaster vases.
Right.
But they want to apply that explanation to these.
And then how do you explain the handles
I
that
don't.
are built into it?
Do we have to like whose job is that?
I mean, how do you do that on a lathe, right? Like how what
You would remove it would be a toroid shape, and you'd remove what's inside of it. And if you actually you want to go back to the heat map of the OG, you can almost see
Yeah.
a line where it looks like it was a toroidal. There you go. See that blue, very faint blue line on the top,
of which one?
parallel with the top handles on the right.
On the OG.
You can see there seems to be a strip,
Oh yeah.
right? So that would have been removed. Your original pass would have left that, and then you would remove it. But look how perfect it's
Right.
aligned to the rest of the body.
Oh wow, that's interesting.
You would no longer be able to spin it.
Yeah, dude, it's so crazy.
So you still have to hold onto these with a rigid,
Right.
massive mechanism or some kind of, I would say, machine. It can be a wooden machine. It doesn't have to be a 5-axis CNC, but still, you can draw a perfect circle, but how would you make it in a very rigid material like this?
I don't know, man. This stuff is beyond my comprehension. I don't know. I can't. It just doesn't compute. You know, I don't know how they could have possibly done this stuff.
The main thing is at the end of this room,
Holy shit!
this is a granite room.
So this room's doing just fine. Doesn't need any.
How have I
retaining
never
walls.
seen this before?
Flinders Petrie said probably this is the most precise artifact ever came out of Egypt.
And this is that Ben right there?
Yeah, yeah.
What is the explanation? What do they say this was, a coffin or something?
Everything's for death. It's all coffins.
It's all for
sarcophagus.
death.
Yeah.
It's a perfectly polished rectangular granite box with looks like it was cut with a laser, dude.
And the bottom has an angle, a constant angle.
The bottom has an
Yeah.
angle. You mean the inside bottom?
Yes, yeah.
If we back up, freeze it so we can see that. But the top,
Holy cow.
the top surface was published. Petrie measured and published it, and he found it to be 0.004 of an inch deviation across about 1.25 meters,
Like flatness.
which is
Right.
I think 20 times flatter than a normal household countertop.
And this entire room is also made out of granite. These are granite tiles. It's crazy. And we actually could measure it. And
So why though? Like the whole thing is like why? Like it's so number one question is like obviously how, right? I mean that's the glaring one. But then once you figure out like why the hell did they have to do this? Because one of the things Chris Dunn says is that coming from an engineering background, you start with function, then you go to design, and then you do like the measurement. So like you start with your function, and then you kind of like engineer it from there. Like what is the purpose of this?
Yeah.
Like then you figure out how precise you have to get to achieve your purpose, right?
or they had the tools which made it easy.
This is
If they had already those tools that could provide these tolerances, they don't have to think about, okay, how should we do this?
right. You
Yeah.
can't see that this is more flat than far less flatness.
So-
And it is possible to do this. In modern lapping methods, this is lapping what would result in something like this, are generally hybrid approaches. There's a machine that's like randomly moving flat, maybe circular surfaces over another surface. And then a lot of times somebody by hand apply some finishing lapping. So
Okay.
it is possible to do this by hand,
Okay.
but you can't see it. You can't see how flat it is. So if this was their target, and look how homogeneous that is.
So-
If this was their target because of the function, like you mentioned, Dan, how would they know when they got there? How would they know when they achieved their target? They can't see it.
So basically,
Unless they would have had to have something to measure it, right? Like they would have had.
you can make a flat surface with the lapping technique, but
It seems like
Those
it's something that's
corners-
almost incomprehensible. It's like I can't think of any way they would have been able to do this.
so we fitted a plane on this can,
Right.
and you can see the green area is around 0.004 of an inch,
Oh my god.
and that's exactly what Petrie measured. We don't know how he measured it exactly, what tools he used in the Victorian era, but
How much does this thing weigh, do you think?
If I had to guess, I'd say like 2 to 3 tons.
2 to 3 tons.
I think much more.
Well, it's hollowed out, so
So it wasn't moved there. It's
well,
been there.
The other problematic issue, as Petrie put it, is that the maximum width coming into this room is smaller than the minimum width of the side of this sarcophagus or bathtub. So how did it get in here? Maybe the room was built around it, though, right? So that's your explanation.
Oh my god.
So
But to what end? And look at the.
How
can't see
deep
that.
underground are we again? 100 feet?
I think a little less. Yeah, 75 feet.
Wow, dude.
It's Kyle.
Wouldn't you love just to get a time machine and just keep going back and see how the fuck this shit was done?
Bathtub time machine.
yeah, this is the other, or the back side of that room. It's almost collapsing.
Yeah. Good lord.
Hopefully this box will be still visible in a few years. They won't close the entire pyramid. I hope so.
What is that they've carved into? Is that solid rock or is it like just compacted mud?
I'm not sure.
There is both because some of the mud brick is collapsed.
Well, I'm sure that's a lot of that's modern and reinforced with different things, maybe even concrete or something like that, just to make it. I mean, that's clearly modern, right?
No, this is original.
This is the original.
Oh, that's original.
This is original
Oh.
granite, yeah.
This is the red granite. So Petrie described these walls as
Oh, it's the
being-
same material as the box.
Yes.
Correct. Ground. They were ground to extreme levels of flatness, but not polished.
But on
So
the
think of
edges, it looks like
sandpaper.
there's some mortar around it.
That's modern.
That's modern, right?
It looks like
Yeah.
it probably doesn't need to be there.
Yeah. Yeah, dude, it's just so insane. Like what? Like why? Why cut a box into something so precise where there's nothing else around it that's as precise, right? It seems to be only this box.
Most of these boxes in Egypt had lids. So
Yeah, the ones in
conceivably
Serapeum had lids.
a lid fit on top of here, hermetically sealed what was inside, which is why you needed the extreme flatness. We don't know if there was ever a top found. We don't know. The dynastics at some point did, I think, bury someone in here.
What is your like wildest hypothesis of like what this could possibly be? Like I know it's not going to be scientific, right? But like, what's your what's your imagine? Like, you just push your imagination to its limits. What do you think it could be?
I think this stuff was repurposed. I think it used to look a lot different, and it's going to be really hard to hypothesize what it was originally used for, what it looked like, but things are moved around.
Chris Dunn thinks they were used to grow crystals. These boxes. Have you ever talked to him about that?
Yeah, it seems as likely as anything. Sure.
It seemed plausible. The way he was explaining to me, I don't remember it exactly how he explained it, but the way he was explaining it seemed very, it seemed like it made sense to me at the time he explained it.
These rooms, these boxes, they're resonant, right? They're harmonically
Right.
tuned. These
Right.
people are obsessed with resonance everywhere, frequency and resonance. So that could fit with that theory, sure.
And do you remember what he was saying about how the crystals were grown?
In Lahoun, in this one,
No, in the Serapeum.
not exactly.
Okay.
Yeah.
Because it has something to do with the boxes being more precise on the inside than the outside. Like the outside didn't matter; it was the inside that mattered.
The volumetric considerations are more important.
Something about the resonance and something else. I would love to hear somebody that could like explain that theory to me. Yeah, that's crazy. He's holding a square tool to the edge of it, and it's literally perfect. There's no gaps with that square tool up against the granite.
And we measure the same, not the same spot, but this same angle. And actually, if you fit planes on both the top and this side, the angle deviation is like 0.25 degrees. So it's 90.25.
That's crazy, dude. And it's polished. You can see his reflection in the stone.
Yeah.
I think the chemical. I think what Jeffrey Drum talks about with the chemicals, using it to scoop stuff out and to soften stuff. I think that makes a lot. I'm not a chemist, but I mean, to my layman brain, I think it makes a lot of sense. And as well as like polishing this stuff. But again, I think these people were just on another technological trajectory than we are on today. And that's why some of this stuff doesn't make sense to our brains. Because just like the way we're going technologically, just like with combustion engines and with electricity, and like that's our foundation for technology, and we like build up from there. We're not really innovating anything different. We're kind of on like a very linear trajectory with our technology, and it seems like they were on a completely different trajectory than we are now, and that's I think why we can't understand it.
Yeah, I agree.
So for people who aren't aware of the Petrie core, I guess the Flinders Petrie found this cored out chunk of granite, I think it is, right? And it has these grooves that go around the outer edge of it. And he went there and took a string and wrapped the string around the groove, confirming that it's a never-ending spiral from one end to the other, right? And because of how close the grooves are together and that it is a perfect spiral, his engineering brain figured out that had to have been a drill that was moving at a very high speed, that was drilling that core out of the rock at like a super high speed, right?
Like 500
Well,
times.
It was a slow speed.
It was very productive. Each revolution was extremely productive.
Right.
We don't necessarily know the speed, but we know that every time it went around, it was removing an extraordinary amount of granite. More than anything I think Chris has said between 100 and 500 times more productive than anything we have
Wow.
right now. But
Here we go.
we asked them about this, and they said, yeah, we have hundreds of these in boxes,
Of these.
drill cores like this. Yeah.
Wow.
They were discarded. They were all over the place, and you could just pick them up off the ground.
So we did laser scan and photogrammetry on this. So photogrammetry is basically a technique where you make like hundreds of photos from different angles around the object, and then you stitch it together by tracking pixels, and
Right.
you can basically there is a representation here how you can imagine the images all around. So these are the images taken of the object.
Yeah, it's like
And-
how they photograph shit for video games.
Yeah, exactly. And the problem with the laser scanner that those grooves are so tiny that it's around the limit of the scanner, of the resolution of the scanner. So we probably have to go back and scan it with a more accurate laser scanner, or a more accurate maybe structured light scanner, because we could reconstruct the grooves, but sometimes the grooves are not obvious where to follow the grooves.
Right.
Because they have like cross sections and
Yeah, it's tough to see it here. You can see the grooves when it gets towards the edge when the light's shining on it, but like the pattern on that rock is like makes it really hard to see.
yes. So we found a few spiral like turns basically on it, but to make sure that it's 100% like a spiral and not just a random wrongly connected groove, we have to go back and analyze it more thoroughly.
Now, I mean, the stuff that Chris has done analyzing this core, I mean, he's done a lot of work, made a lot of videos. He's had aerospace people look at them. I think he had an aerospace guy go with him to the museum. They've filmed wrapping the string around it. Like, where does that go after people like him do something like that? Like, is there somebody like that analyzes that and says like, okay, maybe we need to like rethink how they did this stuff? Or
there should be.
The museum had no idea why this core is so famous. So this is the star object, the museum. But when we were there, they had no idea why. It was surprising to me.
So they don't pay attention to any of this stuff.
I don't think so.
If they consider this alternative archaeology, then generally they ignore it. But there's other researchers that are there during the day, during the week, that they may also ignore just because there's too much on their plate.
Right. The amount of people that are coming in and looking at this stuff, they probably just don't have the time to focus on it.
Are you familiar with Chris King?
No.
His brand is the Chris King Precision Components. He's basically manufacturing high-end hub sets and headsets for mountain bikes and other bikes too. He was with us. So he's a manufacturing expert. He's doing it for like 50 years. Like very tight tolerances, aerospace tolerances. And he was explaining to the museum staff, the archaeologists. So when we were scanning, they were watching us, and Chris was explaining to them why we are doing it and what are the implications. And they were quite open-minded actually. So they didn't refuse to talk about these or.
Yeah, that's what Chris Dunn was explaining to me. He was explaining to me that some of like the younger up and coming archaeologists and Egyptologists in Egypt are way more open to this stuff. And a lot of them even have YouTube channels that explore this stuff and that pay attention to the stuff that like Ben is doing. And, all these like Jimmy Corsetti and all these other guys that are making a name for themselves, questioning the narrative. Like these young folks, these young people who are coming up, they're aware of it and they're actually taking it into consideration. And he's optimistic that dogma is going to change, which is...
I think you can see it already. There's like Ahmed Adli is one of the members of the foundation with us, and he's got a YouTube channel. It's specifically designed to bring this content to the Arab-speaking world because they haven't had it as much as the English-speaking world,
right?
And probably French and German, but it's been absent from their lexicon. So you're right there. I think people are open-minded, and it does benefit them because it brings in tourist dollars eventually.
I would think so.
Yeah. Economically, it makes sense.
So you guys, other than that thing you were just showing, that grid laser thing, didn't you guys also take this to like a defense contractor place where they had some crazy like scanning machines that would analyze it even more thoroughly?
Well, that's right. Before we had, now we have in-house equipment, but in the past, that's the first few places I went. So I went to defense contractor that had access to old CMM machines and structured light equipment, and then we went to Zeiss itself in Michigan, which has like CT.
Zeiss, wow.
They're a massive
lens,
a massive brand that makes exactly like lenses and scanning
yeah.
equipment, camera lenses. So they have CT scanning machines there that are the size of a small room. So obviously, it doesn't lend itself well to on-site or on location. Right. Expeditions or anything in a museum. But if you have the piece, so the private collection stuff can be analyzed at a place like that. And
who have you showed these CT scans to that's involved with conventional Egyptology?
We've spoken to a few. We have some relationships with researchers and academics in Egypt. At the Ministry of Antiquities and other places. So I think we've taken the softer approach where we want we want access to the same sites and the same objects that other academics have access to, and so the first few years I was relatively quiet and we didn't really release anything publicly because it's to them it's important. It could be an existential career question if they want to get involved in the alternative academic community. So,
I don't understand what's alternative about bringing these artifacts into a defense contractor and measuring them. It seems pretty standard.
That work is still above and beyond what's normally applied to this, but the implications could be could be interpreted in a number of different ways. It could be as simple as, well, maybe this culture had something more advanced than they're giving credit to, all the way to it was someone completely different, or it was aliens, or it was high-tech computers, CNC machines, right? So there's a lot of different interpretations that have been applied to this subject. And
so they're afraid of the interpretations.
some are worried that it'll jeopardize their career. They intensely criticize one another over their own papers that aren't even controversial. So if there is something that's controversial that's outside of the mainstream, it could jeopardize their track. It could jeopardize their standing with their colleagues and everything else that comes alongside that, which is understandable. But I think things are starting to change a little bit. The acceptance level is higher than it used to be, especially if we apply rigorous scientific standards.
And if you publish
Yeah.
in a scientific journal.
Right. What do you make of that recent thing that came out with they went under the they found these big things under the pyramids, these big like vertical columns under the pyramids. What do you make of that? Have you looked into that at all?
I have interviewed those two Italian guys. Actually,
Oh, really?
Yeah. Actually, I think they are really smart. Actually, the guy who made this algorithm and this entire, so the engineering part of it, he's also an electrical engineer, telecommunication engineer, holds several masters and a PhD. So he's a brilliant guy. And I think something went sideways with the explanation. So they probably couldn't transfer the full knowledge, and everyone thinks that it's a bullshit. So in my understanding, they are using these satellites to shoot radio waves to the ground, basically, and they are measuring the frequency shift in these radio signals caused by the Earth's crust movements. So if you are familiar with the Doppler effect, when the ambulance car is moving and using the siren, the movement of the car is causing a pitch shift in the sound.
Right.
So basically, when the Earth moves, I hope I can give it back properly, but when
Sounds about right.
when the Earth's crust moves, very low-level seismic activities, they can sense this as a frequency shift.
Right. Okay.
And then they can estimate what's underground. But
and this is new technology that they use to find this? Or is
I think
this stuff
they're-
been around?
the SAR technology
SAR
is
scans,
ex-
yes.
that's existing.
Okay.
Military is using it.
So my understanding was that, from whoever explained this to me, was that whatever stuff they used to detect this stuff under the pyramids was new or something, some sort of novel technology.
Yeah, they refined it to be able to go deeper and to be able to analyze this deeper, basically. But it depends on the model you have out of this
That's crazy.
this bedrock. So you need to have a good approximation of the bedrock. Is if it's limestone, what's the geophysical properties of that block or that stone you are looking at. And a lot of people are confused, probably. What are those rendered images? Like, is it
Yes.
made by AI or something? So
Yeah.
in my understanding, they try to make it more understandable. They can interpret these heat maps and images, but we cannot.
So this image we're looking at right now, Steve, this is that one on the right and the left. Those are like the actual that's the actual data scans that we got from this SAR stuff. And then people came in and did like artistic renditions of it to make it more palatable for people.
They did it.
Yeah. Oh, they did it. Okay.
Yeah, yeah.
And these people have a YouTube channel where they cover this stuff, right? They have these Italian dudes.
I don't think they have. I'm not.
Oh no.
I'm not sure.
Oh, I thought they did. I thought didn't we have somebody who like showed us their YouTube channel, Steve?
I think that was Jeffrey Drum.
No, it wasn't Jeffrey Drum. It was more recent.
This is what you're talking about, the more artsy stuff, right?
Yeah, that's the more artsy stuff.
And they also scan known structures,
Okay.
like the Osiris shaft. Also,
and it was accurate.
I mean, my question is the interpretation. Is it biased because the structure is known, or is it full automated interpretation done by the model they use? So I don't know. I think Kyle from the Snake Bros said once that they should scan something unknown and then excavate it and compare to be 100% sure.
Well, yeah, if you can scan something where you know what's, like scan a shaft or a pyramid's interior where you've already explored it and the data that comes back correlates with what you already know is real, then that's a good way of testing whether this technology works or not. And then if you do something unknown and it shows you something like this, then you should, that's a pretty good proxy for if it's accurate, right? I mean, and then now, I don't know what, if anyone's proposed to try to like dig and explore this or not, but
it would be really hard in my opinion to dig under the pyramid.
It's mostly bedrock, so.
And also the permits and who would allow this. Yeah. Probably a different group has to verify this to get the permit for any digging. But they also scanned 2 years ago the Great Pyramid. This is under the Middle Pyramid. They also scanned the Great Pyramid. And
this was under the Middle Pyramid.
Yeah.
Okay.
And they found hidden chambers.
Yeah, right. They found one the size of a jumbo jet, like above the Grand Gallery, right? Or like a 747. Like that was the size of that cavity that they haven't explored yet.
Yeah.
Which is crazy. Like they did that years ago, and that was the Scan Pyramid project, I believe. And they still haven't like drilled into it or no. Right there, the hidden chamber.
The Italian guys scanned the Great Pyramid and found
those
hidden
guys
chambers.
Found that chamber, that hidden chamber.
No, that's the Scan Pyramid.
That's Scan Pyramid.
The Italian guys, Steve, if you look for or search for Gnum Khufu synthetic aperture radar, it should show the.
Yeah, how long has it been since Chris Dunn found those two electric probes, those two metal prongs at the end of Gatenbrink's door, right? Like they did it on national TV for like a huge documentary, and there's still no explanation for that. What is this? Is this it?
I think that's an AI image on the left. The second image was a little bit better in the result. Yeah, that one. They have also this.
Oh yeah,
render.
I've seen this.
And those chambers are mostly unknown.
So the green one, number
Unexplored.
19, is the big chamber cavity.
Probably
they have not explored yet.
And there are these ramps all around. That's also unknown.
And there's also, which Chris Dunn explains, is there's these big, I didn't know about that until I talked to him, there's these big like holes in the ground on the outside of the Great Pyramid that he says they connect into the shafts that go up to like the King's Chamber and the Queen's Chamber. And
that's the rumor.
He hypothesized that they could have poured chemicals in there and it would have fed up those shafts and like gone through like into the chambers or something like this.
Probably. I have no idea. But I'm sure that a lot of those tunnels under the Giza Plateau probably are connected or were connected to to one of those or all of the pyramids. If you go down to the Osiris shaft, it's like 100 meters deep probably with 3 levels. The lower level is filled with groundwater basically, but there are 1 or 2 shafts relatively closed. I think Zahi Hawass found this in the late 90s or something. They tried to excavate, they couldn't. They faced with like mud, they couldn't go forward, they couldn't proceed. Once they found a small kid in that tunnel, and the kid also, he found a blocked entrance or a blocked tunnel. They don't know what is it connected to. But if you look at the subterranean chamber of the Great Pyramids, I think that's a good option. So maybe the subterranean chamber is connected to the Osiris shaft or one of these shafts.
Well, the subterranean chamber, it's like almost impossible to get a human down there. Like a big person can't even barely get down there,
Into that tunnel.
Yeah, that very bottom shaft where Chris Dunn thinks that there was like a hydraulic device that like hammered the ground and made mini earthquakes, right? And that's his whole hypothesis of how it's like a solid state electron harvester that like
Yeah.
builds electrons through all the igneous rock through the pyramid and like somehow created free electricity or something like this. It's a wild hypothesis, but I mean he's the guy to do it. I mean he literally came up with the whole reverse engineering diagram of how it would work and how those chemicals would interact and how it could theoretically create some sort of free energy. But again, I mean that's applying our knowledge of technology to something that was thousands and thousands of years ago.